Suppose that I roll this die, and let's suppose that in my rolls I get a 5 and then I get a 3. Well, what's the average value of those two rolls? Well, 5 plus 3 divided by 2 is 4, so the average value would be 4. Now let's suppose that I define a discrete random variable, and I want to calculate the average of that discrete random variable. How can I do that? That's exactly what we're going to be learning about in this video. So we have two types of means. One is for data, and one is for random variables. So for data, we have, let's suppose that we rolled a 5 and a 3, so our data would be 5 and 3. The average of that data, x bar, would be 5 plus 3 divided by 2, which is 4. Suppose that we roll the die. What are the possible outcomes of a roll? Well, it's either going to be a 1, 2, 3, 4, 5, or 6, just like I've drawn here. So how can we represent this as a discrete random variable? Well, let's let x be the face value of the die toss. Then we can ask, well, what's the probability that x is equal to 1? Well, since there's 6 sides and each side is equally likely, that's just going to be equal to 1 out of 6. But since all the sides are equally likely, the probability that x equals 1 is going to be the same as the probability that x is equal to 2, and that's going to be the same as the probability that x is equal to 3, and it's going to be the same for all the other sides. And we can put these values in a table. So here we have the value of the random variable x, and there's 6 values, 1, 2, 3, 4, 5, and 6, and the probability here, and each has probability 1 out of 6, 1 out of 6, 1 out of 6, 1 out of 6. So now we can ask, what is the expected value or average value of x? Well, that's just going to basically be 1 times 1 out of 6 plus 2 times 1 out of 6 plus 3 times 1 out of 6 plus 4 times 1 out of 6 plus 5 times 1 out of 6 plus 6 times 1 out of 6. And that value is equal to 3.5. But now this is the same as 1 times the probability that x is equal to 1 plus 2 times the probability that x is equal to 2 plus 3 times the probability that x is equal to 3, all the way down to 6 times the probability that x is equal to 6. And sometimes we write that this is, instead of writing 1, we write little x subscript 1 times the probability that x is equal to little x subscript 1 plus x subscript 2 times the probability that x is equal to little x subscript 2 plus x3 times the probability that x is equal to little x subscript 3 plus all the way down to x6 times the probability that x is equal to little x subscript 6. So the mean of any discrete random variable is basically an average of the possible outcomes. So in the die example, we had the possible outcomes are 6, 3, 1, 4, etc. So basically we're going to average those possible outcomes. But what do we average them by? Well, we average them by the probabilities that they occur. And so values that occur with greater probability get a higher weight, and values that occur with a lower probability get a lower weight. But in this case, each of the possible values of the die occur with equal probability. Here's the general definition. The general definition of the expected value of a discrete random variable is given in this formula outlined here. The values of the random variable, x, can take on the values x1, x2, all the way down to xk, and the probabilities are denoted by the probability that x is equal to x little x1, the probability that x is equal to little x2, and the probability that x is equal to little xk. So how did that work in our dice rolling example? Well, k in that case was equal to 6, and x1 was just equal to 1, x2 was equal to 2, and x3 was equal to 3, etc., and x6 was equal to 6. And the probabilities, the probability that x is equal to x1, it was the same as the probability that x is equal to x6. They were all equal. They were equal to 1 out of 6. And then basically we would take these values and plug them into this formula.